Okay, we're still in section 1.1 and we're doing the exercises now at the end of the lesson in the Stewart's Calculus 7th edition Early Transcendentals textbook, and I'm going to do problems or exercises 31 and 32 for you. And in these exercises the question says to find the domain of each function, and in 31 we are given the function f of x is equal to x plus 4 in numerator and x squared minus 9. Alright, so we know the denominator can't be 0. So any number that when input into x makes the denominator equal to 0, we have to exclude that number out of our domain. So what number, when input into the denominator x in the denominator, causes it to be 0? Well, we could set this whole thing equal to 0 and solve for x, but it looks like we have a really easy answer. For example, blank squared equals 9. Well, 3 squared equals 9. So 3x should not equal 3. However, what else squared also equals 9? Negative 3, right? Negative 3 times negative 3 is 9. 9 minus 9 is 0. That's why negative 3 doesn't work. 3 times 3 is 9. 9 minus 9 is 0. That's why 3 doesn't work. So we have to exclude 3 and negative 3 from the domain of f of x. So our domain is x such that x does not equal 3 and negative 3. In interval notation, it's negative infinity, all numbers from negative infinity to negative 3 non-inclusive union, and then negative 3 to 3 non-inclusive union, and then 3 all the way to infinity. So that's the domain of 31, the equation in 31, the function 31. Alright, the next function, or the next problem, 32, gives us f of x, good old f of x, is equal to 2x cubed minus 5 over x squared plus x minus 6. Okay, so this one needs to be factored in the denominator. Okay, and when we factor it, you should get x minus 2 factor and x plus 3. When you multiply these things out, you FOIL and you should get x squared plus x minus 6. So when we input 2 into here, we get 2 minus 2, which is 0, and 0 times anything is 0, which makes the whole denominator 0. So 2 we have to exclude from the domain. So in this equation, or in this function, x cannot be 2. And negative 3, when you put in here, negative 3 plus 3 is 0, and it makes the whole denominator 0. So you cannot have negative 3 in this domain. So the domain, I'll do it in orange, of this function is negative infinity to negative 3 union negative 3 to negative 2 union, oops, don't do that when you do union, and then 2 to infinity. So any number in these intervals except 3 and except 2 is perfectly acceptable to be put in as x for this. And if you do graph this, the graph looks something like negative 3. Oh no, negative 3. What was the other one? 2? Yeah. I think it was something like this, and then like that. I remember graphing it on my graphing calculator earlier just to confirm that the zeros, or the points that are undefined on the graph, were 2 and negative 3. There is a what's called a vertical asymptote at those points. And the graph never crosses a vertical asymptote. Sometimes a horizontal, but never a vertical asymptote. And these are where you will have your zeros on the graph. So that is 31 and 32. Alright, stay tuned for more exercises.